So, funny story, I've already recorded all these videos, but I happened to be on mute the entire time I was doing it. So, I get to do them again, which is really exciting. Okay, 6.3, polar coordinates continued. What we're going to do in this one is converting between polar and rectangular equations. So, I'm kind of exploring what that means. Okay, the idea being, like this equation, x plus y equals 5, is in the rectangular plane, right? It's just a linear function, y equals negative x plus 5. So we're talking about an x and a y shifted up 5 with a slope of negative 1. Cool? I don't know if I just said that backwards or not. With a y-intercept of 5 and a slope of negative 1. Okay, I don't know if I did or not. But whatever. Okay, what I want to do is, could I also graph that using radius and angles, right? Using rotational orientation. So with with this expression, I've got x's and y's, and what I want to do is get it in terms of r's and thetas. So I can see right here that I've got x equals r cosine theta, and y can equal r sine theta, and then that would have both r's and thetas, but we'll mess with it from there, okay? So x equals r cosine theta, y equals r sine theta equals 5. So technically I do have it in polar form, but we do want to solve for r if at all possible. So I notice that there's an r in both terms. I'm going to factor it out. Cosine plus sine equals 5, and then we divide and we're done. So r equals 5 divided by cosine theta plus sine theta. This one's not as cute to graph by hand, so I am just going to show you in the calculator right quick that we get the same thing. So I'm going to go to y equals, and I'm going to type in 5 divided by cosine. Now, whenever I push, yeah, I should talk about that. Mode. I'm going to go to polar mode, because that's what I'm trying to graph. And so when you go to polar mode and you go to y equals, it now says r equals, which is why we try to solve for r in order to be able to graph it in the calculator, right? So cosine. Now, when you're in polar mode and you press this button, it'll be theta. Okay. When you're in function, it'll be x. When you're in parametric, it'll be t. And then sequence, it'll be an n. So plus sine of theta. Okay. And then window. So we're talking radian. We're talking about radians or degrees, right? So I could say from 0 to 2 pi, which is what that is right now. And then this is just some kind of step, like however many degrees I want it to go by. So it's like, do I want it to graph every 30 degrees? Do I want it to graph every degree? Do I want it or every, eighth of a radian, so it depends on what unit you're in. So right now I'm in radians, so I might say like, every pi divided by 36. So we're talking, taking the top half of the circle, right, pi, and dividing it in 36 ways. And then I have the x's and the y's set up like this because I did zoom square, and so it would be a square graph. But anyway, and you can see that you get the line. Now it's a weird way of graphing it because it goes back and forth depending on the degrees, but or depending on the radians. But that's it still graphs the same function. Now if I'd gone to mode and I said be in degrees, then on my window I would have said 0 to 360, and then I could have said, hey, graph every 1 degree. And so it would take it a while, but it would graph every degree as it goes, right? And so interesting that it starts here, it goes up there, kind of depends on the angle that you're at, and so once it gets to these other angles, then it comes up here. So anyway, it eventually creates the line. Kind of interesting. Okay. So we got that one into polar form. Now let's talk about this one. Okay, if I asked you to graph the function x minus 1 quantity squared plus y squared equals 1, then I would expect that you would recognize, oops, sorry, it's kind of switched over, that you would hopefully recognize this as the equation of a circle. So x minus h quantity squared plus y minus k quantity squared equals r squared is the equation of a circle centered at hk with a radius of r. Okay? So in this case, we've got a circle centered at 1, 0, so opposite, and then there's nothing there, with a radius of r, with a radius of 1, because 1 is 1 squared. Okay? Okay, so I know how to graph that. If I'm graphing in the regular XY coordinate plane, then I would say, hey, go out one and then create a circle, right? So I wouldn't necessarily see this circle. I would see just an, you know, I would see the grid, and then, uh, rectangular lines, and so anyway, then I would have to create a circle and say, okay, there's my circle. Oh crap! It's not centered there. It's centered at 1, 0. So it would be over here. Yeah. Okay. So that's not going to be good to draw it. So I will use. I'll just use this one and call it good. Okay. So if I centered it at 1, oh yeah, okay. Then it would be like this. So I'm trying to, as if it was on the regular XY coordinate plane. So I should get a circle like that. Okay? Now what we're going to do is we're going to prove that whenever I graph this using the... I really don't like that. Sorry, give me a second. Okay, I'm going to use this one I used earlier when I graphed it, or when I did the video before. Okay, so we've got the origin, and we've got the rectangular plane with the grid, and then we've got the polar plane with that, right? So if it was on the rectangular plane and I said this is 1, this is 2, this is 3, this is 4, right? Then a circle centered at 1, 0 with a radius of 1, so that would mean here, 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 and here, right? And so you can see that you would get this circle. Now what I want to do is I want to graph the same thing using the polar version and see if we get the same graph, okay? Alright. I liked my graphs better before. That's okay. I'm going to go back to this being 1, and 2, and 3. Okay, so here we go. I have a couple options as far as converting this into polar form. So I'm going to do what I think most students would do without having been exposed to any shortcuts first, and that is just a straight up replacement. X equals r cosine theta. So r cosine theta minus 1 quantity squared plus r sine theta all squared equals 1. So I've replaced every x and a y with the r cosine and the r sine. And then I would expand, right? So r cosine theta minus 1 times r cosine theta minus 1 plus, and when you square a product, you're squaring each term. So r squared sine squared equals 1. R cosine theta is one term, and r cosine theta is one term. So when I multiply, I'm multiplying both of those. So r cosine times r cosine is r squared cosine squared theta. Minus r cosine minus r cosine, so that's minus 2 r cosine. And then plus 1. Plus r squared sine squared equals 1. Okay? So something you might notice is that if you subtract 1 from both sides, you end up with 0 on the right hand side, so that's nice. And then I'm going to do another thing. I have r squared cosine squared minus 2r cosine plus r squared sine squared, and I want to be able to solve for r. What I want to do is I want to get these two terms beside each other. R squared cosine squared, and then plus r squared sine squared minus 2r cosine theta. And then I can tell, hopefully you remember, that we have a shortcut going on here. Or we have a trick, or not a trick, we have an identity we can use to simplify this expression. These both have an r squared in them, so if I just factor an r squared out of these two terms, right, so just these two terms, cosine squared plus sine squared, we hopefully remember, is 1. So I'm left with r squared minus 2r cosine theta equals 0. Okay? Then, if I'm trying to solve for r, I I can't add this over and then divide by r, although technically that would get you the equation. It's not done, I guess I should say. It's recognizing this. I've got two equations, r equals 0 and r minus 2 cosine theta equals 0, or r equals 2 cosine theta. So let's look at this first, okay? Radius equals 0. That is the entirety of the equation, right? Well, if I told you, hey, radius equals 0, hopefully you would know that, well, we're dealing with a circle and the radius is 0, which means it's literally nothing, okay? So, okay, technically adding this and dividing by r does get you the answer, which is r equals 2 cosine theta, but that is not a very good way of getting there. But my point is to show you that this equation is equivalent to this circular form, or this standard form of the circle. Okay? So here we go. My equation is r equals 2 cosine theta. What I'm going to do is I'm going to graph, I'm going to plot points, and first off I'm going to remind us of some coordinates. This is 1, 0, this is square root of 3 over 2, 1 half, square root of 2 over 2, square root of 2 over 2, 1 half, square root of 3 over 2, 0, 1, and then negative 1, 0, 1 half, square root of 2 over 2, square root of 3 over 2, 1 half, negative, negative square root of 2 over 2, and negative square root of 3 over 2. Okay? So, here we go. If I asked you to graph, find the r when theta equals 0 degrees, or 0 radians, whichever one you want to do. Okay? If theta is 0 degrees, now I'm putting it like this, but remember that as far as coordinates go, in polar we do r and we do theta, but it's easier for me to like plug in theta and get r. So 0 degrees, if I plug in 0, cosine of 0 is 1, and 1 times 2 is 2, so that would be 2. So the point 2, 0 degrees would be, rotate 0 degrees and then go out 2, a radius of 2, and plot your point. Okay. Now let's go 30 degrees. So if I go 30 degrees, then that would be cosine of 30. Cosine of 30 is square root of 3 over 2. Square root of 3 over 2 times 2 is square root of 3. Now square root of 3 is 1.7 something, I'm pretty sure. I'm just going to check real quick. Yes. It's like 1.732. Okay. So if I rotate 30 degrees, then I would go out a radius of 1.732. So 1.5, 1.7-ish, somewhere in there. Okay. Then if I go 45 degrees, then cosine of 45 degrees is square root of 2 over 2. So square root of 2 over 2 times 2 is square root of 2. So I've got square root of 2, comma 45. And square root of 2 is like 1.4 something, 1.414. 1.414. So at 45 degrees, I'm going to go at a radius of 1.414. Halfway is right there, so 1.414 would be a little less than halfway. And then 60 degrees, so 60 degrees, the cosine is 1 half. So cosine of 60 degrees, 1 half. 1 half times 2 is 1. So it would be rotate 60 degrees and go out a radius of 1. So rotate 60 degrees and then go out a radius of 1. Okay? And then if we go 90 degrees, then we would get cosine of 90, which is 0, and 0 times 2 is 0. So we are at 0, 90 degrees. So rotate 90 degrees and go out a radius of 0, which puts me there. Okay? In fact, if we were to do 15 degrees, right? If I were to type in cosine of 15 degrees times 2. Let's see if I'm in degree mode. So 2 times cosine of 15 degrees, and that would give me 1.932. Yeah? So at 15 degrees, I would be 1.9 something, so that would be like really close to that line. True? So you can see how it would get us closer and closer to the circle shape the more degrees I did. So if I do, let's see, 75 degrees, right? 2 cosine of 75 degrees. I get 0.5176. So if I rotate 75 degrees, which is right here, then I get 0.5, so that would be somewhere in here. And you can see how we get this circular shape, or so far we've got a semicircle. Okay, now I'm going to keep on rotating, right? So it looks like I should go down here. That's not true. I'm going to keep on rotating. I went to 90 degrees, now I need to go 120 degrees. So 120 degrees. Cosine of 120 degrees is negative 1/2, and negative 1/2 times 2 is negative 2. So the coordinate point is now negative 2, 120 degrees. So I always rotate 120 degrees, right? My radius is 2, but it's negative, which means I pop over here. And so now we are, oh, that should be negative 1. Just kidding. Negative 1. What? Okay, I'm going to pick up the rest of that problem in just a second. Nope. Yep, you stay. Okay, I'll pick it up in just a second.